I hope today you all will be very much enlightened with Bhaktiar's lecture. Now over to Muhammad Bhaktiar Rahman.
Thank you, sir.
Here the students are coming from India and Bangladesh. Some students are from Bangladesh, some students are from India. So please
Okay.
start now, Bhaktiar.
Okay, sure. Um,
Do you want to share your PPT? Bhaktiar is teaching from Bangalore now. Maybe there is some network problem. I'm not sure. Bhaktiar, are you here? Sure. I think Bhaktiar has some network problem.
Hello.
Well, Bhaktiar has joined now.
Yeah.
Over to Bhaktiar, please start.
Sorry, apologies. I had trouble getting into the meeting. Yeah. So, sir, I think
You want to share the PPT?
not PPT, but yeah, while I want to do that, I will rather use the whiteboard. Let me know if everyone is able to see the whiteboard.
Yes, visible.
Okay,
It is
great.
visible.
Yes. So, uh, while I start the session, just before we start the session, quickly, can each one of you finish a round of your introduction?
Hello, sir. I'm Shubham. I am currently a research scholar in the Department of Psychology, Banaras Hindu University, and in my third year of my PhD. So that's what was a quick info of mine.
Okay. How about the rest? Guys,
Hello,
please be my
Amit.
guest. Please introduce yourself one after the other.
This is me, MD Rafi Rahman. I'm currently studying in MS. I'm currently doing my master's on school psychology at University of Dhaka.
Thank you. Who's next?
Hello.
Yes, we can hear you.
Good evening, sir. Myself, Dr. Amit Tirpude. I'm from AIMS Raipur. I'm associate professor in anatomy.
Thank you.
Good evening, sir. Good evening, sir.
Good evening.
I am Kavita Rao. I am research scholar in West Bengal Health University. I am pursuing PhD in 2 years in part time.
আমার এটা চেষ্টা করে পরে বন্ধটা যায় না না এটা তুমি চলে আসতে পারো শাল ব্যবহার করতে
Yeah, can you please mute yourself when you're not speaking so that it's easier for others to introduce themselves? Yes, Miss Sahu, you can introduce yourself now. All right, so if no one is left, we'll start the session. Okay. As I said, as mentioned by Professor Roy, the session is on multivariate regression analysis. Okay, so under multivariate analysis in principle, we will take a close look at two different methods for different data types. Okay, so the first method in general is extension of simple linear regression that I suppose have been taught already by Professor Roy. And the second method is also extension of simple linear regression, but for a different kind of data type where your data is more or less in binary form or not a continuous data. Okay. So okay. I see some of you trying to be artistic on the whiteboard. If you mind, please do not do anything on the whiteboard. I will use the whiteboard for illustration. Thank you. Yeah. So before we take a look at the data, let's start with understanding the concept of regression. Okay, so I'll just give you a brief overview of the concept, and then I will show you the data in a spreadsheet first. Okay, so the data that we have to model, we take a good look of the data, and then we understand the features of data. As a practitioner, if you do not understand the features of data, then you're not doing justice to your analysis. Okay, so, and while I'm explaining, if you have any question, please feel free to use the mic and ask your questions. Okay, so I'll speak through the session, and at the end we may or may not have time for questions. So as in when you have a question, feel free to stop me and raise your questions. Great. So regression, regression in general is a concept where we use data from the past for two purposes. One is to understand the past, and second is to see if we can forecast into the future. Okay. Now, the method that we will discuss today is more about using regression and understanding the past. For example, you wish to predict or you wish to understand how the GDP of a country is doing. Okay, so let's take GDP of a country as an outcome that we wish to understand, and let's take another factor, that is industrial production, and we want to understand GDP with respect to industrial production. Okay, so let's suppose, let's say we have data for last 50 years. So we have 50 data points in time, okay? And using those 50 data points, we're trying to model GDP against industrial production to understand how the GDP of a country has behaved over time. So let's take two different axes and plot some data. So you will see a few more dots than 50 here, and this is merely for illustration, okay? So when you do a regression, your objective is to draw a line, okay, that explains the variability in your data. And it is modeled by the equation that is beta naught plus beta 1 to x. Okay. Are you with me?
Yes, sir.
Are you with me till here, everyone else?
I can hear you, sir, but for network issues, sometimes your blackboard, whiteboard is getting not receiving. I'm
Actually,
hearing.
the whiteboard miss our commands get hidden in the whiteboard. So even if we touch, there is something happening on the whiteboard. You are audible, sir. No problem. You just carry on.
Okay, thank you. All right, so sir, I suppose you have everyone's email ID. After the session, maybe sometime next week, we can send you some learning materials in PowerPoint. Even if you like, in case you miss out anything on the whiteboard, you will find it on the PowerPoint. So do not worry about it. Okay, but hopefully the network stays stable and you're able to see the illustration on the whiteboard. And soon after this, I will take the control and show you the actual raw data that we will try to model in the next session. Okay, so yeah. So beta naught basically here is your intercept. Okay, mathematically, this is your intercept. And beta 1 here is your slope of the line. Okay, now what we try to do here is fit this line in such a way that it explains maximum variability of the data. So the data that is your Y could vary from, let's say, your GDP could vary from something as low as 2 to as high as 10. Okay. Now, for us to understand why it is varying from 2 to 10, we have measured it against another variable for the same time period, that is IIP, okay, which is your industrial production. Now, this is basically your simple linear regression, okay. To this, if you start adding multiple variables, okay, so to explain why GDP is behaving the way it is, if you start adding more variables, something like your exports, okay, imports, which I wouldn't say, let's take this out. It actually a part of the formula that constitutes GDP. So let's take that out. Okay. Okay, so let's pick up an interesting variable which no one tries to study, and that is your population growth against GDP. Okay, let's pick up another variable, that is your literacy rate, or instead of literacy rate, we'll say high school education. Okay, so we have three variables where industrial production, population, and high school education. Now, using these three variables, we try to understand why the GDP is varying. So in principle, regression is a tool that helps you understand the variability in your dependent variable in the past, okay, which can be used to design your future programs, policies, to improve the GDP in our case. Okay. Now, when you have more than one variable, that is your explanatory variable, illustration on 2D becomes difficult. Okay, so basically you look instead of 1x, okay, we take it from 2 dimension to the number of variables we have. So in our case, we have 3 variables, so it's 4 dimensions against, okay. And graphically representing this data is a bit difficult. However, your mathematical equation remains same. So here for multivariate, let's say ym is what I use to denote multivariate regression. Your equation will remain like this: beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So we take something from each of these variables to explain why. Okay, and that's how we are able to explain the variability on y. Okay. Our objective is to figure out a line that explains the maximum variability. So through iteration, okay, we will fit multiple lines into this model, and we will select a line that explains maximum variability. Okay, so to evaluate the performance of a regression model, we use multiple metrics. Okay, and one among that is R squared. Okay, R squared explains the total variability in the model, that is explained by all the factors put together. Okay, so iterations are something that we do mathematically. Okay, and in general, we use techniques like gradient descent to figure out the lowest minima. Okay, so sir is covering gradient descent in scope for this session, or is it out of scope? Are you around, sir?
Hello.
Okay. Yeah. So Shubham
Yeah,
has a
whatever you have
question.
taught, I have already taught them. This part I have already taught them.
Okay.
But this is about the iterations. So these iterations are important to control the multicollinearity. So I think now Shubham can understand.
Yeah. So is gradient descent within scope of this session?
No, this gradient, I think they have no idea.
Okay.
This mathematical model, they have no idea.
Okay. So let's leave it. Okay. Shubham, you don't have to worry too much about that. What I can tell you is when we run the model, the algorithm in the background will figure out the minima and fit the best line. Okay, so if you understand the mathematical model, it is good. If you do not, you do not have to worry. I think sir would have already shared the measures, okay, to identify if your model is performing good. Okay, so what sir was talking about is multicollinearity, and to assess multicollinearity, we use a factor called VIF, which is variance inflation factor. So what variance inflation factor does is it helps us identify variables that are influencing the outcome of the model, okay, whether it is underfitting or overfitting, because one or two variables are related to each other. So using this, we eliminate some of the variables to make the model more compact and useful. How do we go by VIF? So a rule of thumb is, in general, the practice within industry and academia is for any variable, if the VIF is 3 or above, we tend to remove that variable from modeling. Okay. I do not have much explanation, but in general, 3 is considered pretty high. If you go at some other fields like medical or banking, where the variables are in hundreds and sometimes in 500s or thousands, a VIF of 2 is applied as well. Okay, but in general, in social sciences, you will not see anything below 3. Okay, great. So, sir, can you give me the access to share my screen?
Yeah. Because you are sharing the screen, so I cannot do anything.
1 second, let me close this.
Yeah, now I can work.
Thank you, sir.
So if I'm doing a research in social sciences and I find that there's this variable having VIF more than 3, then I will not keep it in the model, right?
Yes.
Yes, now you are the host.
Thank you, sir. When everyone is able to see my screen.
Yes, visible.
Okay. So this is some of the data that I have from one of my research, okay, that I engaged in many years back. Okay, so it was open research for the industry participants and some students, student interns who participated from various industries. So when you see a data set like this, your first objective is to understand the data set. Okay, I could have straight away jumped into something like a R or SPSS and modeled the data. But for someone analyzing data, it is unjust if you do not understand the principles of your data, okay, and how you're going to model it. So let's take account of the number of variables that we have. Okay, so if you look at the number of columns we have about 100 columns, okay, and in this case, our dependent variable is overall effectiveness of a team. So this was a survey research that was done to understand what improves uh, over effectiveness of an organization and a team, okay, using multiple factors. Some of these factors are demographic, that is to understand the variation within groups, okay, and similarities or dissimilarities within groups. So most of these variables are items from a survey instrument, and these survey instruments were in form of questions, okay, measured on a Likert scale. If I remember it correctly, they were between 0 and 10. Okay, so let's do a transpose of the. Okay, sorry. So the objective here is to show you this data, and before we get started with analyzing data, okay, or even look at the properties of data, let's look at the data type. Okay. So these are my variables, okay? So as you see, some of these are demographic variables, which is your organization name, gender, uh, primary language, age, working department, education level, work experience, caste, religion. And then you have questions, okay, itemized questions for each of the constructs. So in social sciences, a construct is formed by multiple items. Sometimes it'll be one, two, or more than two. And depending on what construct is, it'll have the number of items. So there's a lot of research that goes through before deciding what kind of items are chosen for which construct. Okay. So what you see here is these questions are individual items, and total score is the sum of these items. Okay. And then we have, likewise, we have multiple items, okay, which are measured on Likert scales. Okay. And for each of the construct, we have a total score, which is summed up on all the items. And then if you go down, okay, we have taken some of these constructs to form overall effectiveness of the team. So the team effectiveness score is nothing but it's a sum of all the final scores that we got from each of these constructs. Okay, so any questions here?
So how did you calculate the overall score of the CQ scale?
Sorry?
How did you calculate the overall score of the cultural intelligence scale?
Yeah, so it is some of the individual items for the construct. So for example, let's take this. Okay, so you see here, this is total metacognitive score, and it is your total of these items. Okay, that makes your metacognitive score. Wait, am I missing something? Ah. Yes, so each response for all the items is summed up, and that makes your total score. Does that clarify?
Yes. My question was about
It is the same
overall
process.
scale. Overall,
Yeah.
overall the 20 items. Same
Yeah,
process.
it is the same process. Okay, what happens is you have these totals. Okay, so construct total is averaged for your effectiveness. Make sense now?
Yes.
Okay, so now let's look at the columns one by one. We will not look at the items, all the items, but we'll look at a few of them, okay, just to get a hang of what the data is. Organization name, okay, so this is in principle your text data, and this will be converted into nominal data when modeling. So nominal data is like any number between 1 to 10 to represent a category of individuals or a group. Okay, so all we have to do is figure out how many unique organizations are there, and each organization will be assigned a label. Okay, and that does not have any impact on your modeling. These are basically groups that we are creating, or by very nature of the way the data is collected, these groups are inherent to the data. And at some point, we would want to understand the variation between these groups. Okay. Then we have a second variable, which is gender. It is also in text form. When converted for analysis, it'll be in nominal scale 1 and 2. Okay, so you can assign 1 to a female and 2 to a male, 2 to a male or a female. It does not matter. If you reverse the numberings, it will have no impact on your analysis. All you need to do is have a dictionary where you can reverse map what numbers assigned to which category. Likewise, we have a category for the language that the incumbent spoke. Okay, and then we have age group. Now let's look at this. Interestingly, age group is a numerical category, but because we have it in a range format, okay, it will also be treated as nominal data. So we will see how many ranges we have, okay, whether it falls between 33 to 42, 22 to 32, or something below or in between. Okay, each range will be assigned a label, a numeric label, and that's how we'll analyze the data. Okay. Likewise for working department, likewise for education, again, work experience. So work experience is also numeric data, but because we have taken a range, it will be treated as a nominal data, and we will assign a numerical label. Okay. The same goes for caste, and same applies for religion as well. Yeah. So for analysis purpose, let's pick up this item. Okay. So at some point, we will analyze the items. At some point, we will have to take the aggregate scores of the item, which is this. Okay. Now, what happens here is the way we analyze these items is slightly different from the way we analyze aggregate score. When we analyze aggregate score, it is more to use them as an independent variable for modeling or explaining the total variability of the team effectiveness score. The way we analyze this independent items is to understand the relation between each of these items, okay, and how they impact the total cognitive score or their individual relation with some of these items that you see here. Okay. So this way you get to understand if items from one construct are related to other and they are influencing the outcome or the variability of team effectiveness score that is right at the end here. Okay. Right. So I'm going to take a moment to pull up the tool on my screen, and hereafter we will do all the modeling on the tool. So let me know when you're able to see our studio on my screen.
Sir, excuse me.
Yes.
Sir, just can you just summarize the whole context again, please?
Okay, no worries. Yeah. So the idea of looking at a spreadsheet is to understand your data. Okay, it is to get a feel of your data. So in summary, you would, as an analyst, you would like to understand how many variables you have. So your number of columns is the number of variables that you have. Okay, we have 100 columns, and each column is a unique variable. Okay, now we would also want to understand what data types are available. So broadly, in this data set, we can classify data into two types. One is the survey responses of the individual because it's a survey questionnaire. And second is the demographic response. So demographic response is collected in any survey to understand what groups exist within the data and how they vary among themselves, how the data varies within the group and between groups. Does that answer your question?
Yes, sir.
Okay. Right. Okay. Are you able to see my screen?
Yes.
Excel sheet is visible now.
Okay. Let me pull up our code. You should be able to see that.
So, Bakya sir, I was asking about the scoring scale because this is the same scale that I am using in my PhD.
Okay.
And in the mail correspondence of the with the like the Ang ma'am, so she was the one who created that scale. She suggested me if you want an overall CQ score, you average the averages of the 4 dimensions. I just wanted to ensure whether this is the
Yes,
same.
That is exactly how it is done.
Yeah, averaging averages, right?
Yes.
Okay, okay.
I'm trying to reshare it. For some reason, the data doesn't seem to come up. Okay, allow me a minute. I'll just drop off the call and rejoin. I think when I do that, I'll be able to share the screen. For some reason, it is not allowing me to. So be patient. Give me a minute. I'll rejoin the call.